Who are we?
We are Adam Up Maths.
What do we do?
We find fun, innovative, and creative ways to teach basic math skills.
What can we offer?
We can offer free video resources, mostly in the form of song. We've got games, other visual resources, lots of fun, colourful things that children can use in schools.
Who is Adam Up?
Adam Up is an alien who goes on adventures around Numberth in the hope to find his long-lost mother, encountering lots of maths problems along the way, which he has to solve.
Describe the videos.
The videos are short, catchy, colourful videos used to help understand key vocabulary or basic math skills.
How much does it cost?
Absolutely nothing.
Here we go.
Okay, so episode 2 is all about square numbers. So the first thing we're going to do is, Sam, can you describe to me what a square number is?
Yeah, well, simply it is a number multiplied by itself gives you a squared number. And it's one of those, I think this is a good one to do first, because it's one of those things that as teachers you think, oh, everyone knows square numbers, it's easy. And then you're teaching older children in secondary school perhaps, and they don't know what it is. And you're often surprised. You think, what do you know what a square number is?
In a functional sense, why would we need to use or understand square numbers? How is it useful in everyday life?
I suppose as you get older, things such as looking at surface areas, to do with painting, and possibly to do with patterns, tiling, all that kind of stuff. But it really is one that I think it is hard to sell genuinely as an everyday thing that we use, which is why I think that sometimes, and we'll get onto this in a bit, we need to look at the context, perhaps not necessarily in a functional way, but still in a way which entices children to want to learn it.
I was observing a lesson yesterday, and they were doing the White Rose scheme.
Are we allowed to mention other resources on this?
Yeah. All right, they were doing a scheme. They were doing like an assessment activity where they had the concrete pictorial fluency and the reasoning problem solving, and it was all about arrays. Now, I was thinking, actually, if you've got an array that is equal amount of columns and rows, is that not a square number?
Yeah.
So actually, there's lots of things in life, and what they found difficult, most of the students, was they could work out how to count individual. I think it was cupcakes. You could do maths with everything with cupcakes, can't you? But they were either counting every individual cupcake to get to the answer, to find out what the total is in each array, or they were going 5 add 5 add 5 add 5 add 5, and they weren't able to visualize or understand why multiplication would have been a quicker way. So then we had to go right back into what is multiplication in order to achieve that little part of their assessment.
Mm. Yeah, I think that's something that only really clicked with me, having started working at a special educational needs school, is understanding what multiplication is something we take for granted. Adam Up Maths, putting the fun in fundamental. So what I've got here, I've got two different kind of contexts that I'm going to share with you, and then you can critique me, or you can slam it down like you often do, or you can praise me.
Can I just say at this point, I've got a very whistly nose, and I'm trying not to breathe, but then I'm struggling to, so I apologise.
Okay, so the first context is sort of very much an Adam Up context. And I'm thinking about Adam Up and Millimeter, and they're in the land of problems, and they've got a swamp, and they've got to cross the swamp from one end to the other. You look very concerned.
I'm just trying to breathe.
Oh, okay. And between the swamp, there are stepping stones in pairs of stones going across the swamp. And written on all these stones are numbers. And so they've got to take their first step, and they either choose the stone on the left or the stone on the right. And one of those will be a square number, and the other one will not be. And so they've got to get from one end to the other. Now, if they step on the one that is not a square number, then the colossal squared. That's a little play on colossal squid.
No. I know what's going to happen. They're going to fall
Yeah, they're
into
gonna
the
get
swamp.
And they'll get eaten.
Oh,
Exactly. So, at that point, the children who are learning this need to know what square numbers are. And they could have a guess, and they could just do it by trial and error and say, oh, I'm going to jump on this one, it's 16. And it's, oh, good, it works. But they don't know why. And they go to the next one, 48. Oh, no, you're in the swamp.
yeah. I like that.
So, now,
So
that
some
is,
students
that
can
is,
just memorize. It's a bit like, sorry if I interrupt,
yes,
Sam.
no, that's okay.
I remember teaching my son times tables when he was very, very young, kind of maybe 3. And he struggled with remembering 6 times 6, 7 times 7. So, and he just remembered them 6 is 36, 6 is 36. And every time I'd cross him, every so often I'd say 6 is 36, 6 is 36. So sometimes just learning by repeating, almost like learning a script, works for students, as long as it's not too wordy and as long as not asking them to learn too much. So something like that game would be really good.
Yeah, I mean, and it's not at that point that you expect the children to work out what they are just by trial and error completely. That's just the starting part of the process, and it's giving them a bit of a reason to want to know how to solve the game without doing trial and error. So you start with trial and error, but then you want to, you will come in and you will show them how to do it afterwards, and that's where we'll come on to the songs and the models and the other practice. So the thing I want to talk about briefly on this is that that is not an everyday functional context. But it's a bit of fun. So I think we can kind of distinguish between 2 types of context we probably use as a theme throughout all these podcasts. That one is one that's kind of in a fantastical world, and it's a game, and it's a bit of fun.
Well, it's funny you should say that, because this morning I got out of the house and there's this massive swamp. There's these square numbers. There's a 4 and then there's a 5, and I trod on the 5 and it wobbled a bit. Carry on, Sam.
And the colossal squared got quite angry.
Yeah.
And so I was looking at the ages in which children learn square numbers in some different countries. In the US, they first learn it when they're aged 10 or 11. And in England, when they're 9 or 10. And New Zealand, it's a bit slightly different there, but probably from about the age of 11 up to 14. So for those younger children who are learning it, how much depth do we want to go into something really functional like tiling and painting and stuff like that, which they're not really going to be doing? Whereas if you present it as something kind of silly, but they've still got a reason to do it, then to me, I think that works.
I'm listening.
Oh, good. And okay, so that's sort of my add 'em up kind of type one. Then thinking about maybe some older students, some of the students that we've taught before who are just starting to learn square numbers at an older age, later in school life, or children in mainstream as well who need a refresher. And you probably do want something a bit more real, a bit more functional. The one I was thinking would be quite good would be going back to painting, working out if you've got the length of a wall, which is a square-shaped wall, then working out how much it's going to cost to paint that wall. And so they'd need to find out what the area would be, look at the sort of the spreading rate, how much 1 litre would cover, 1 litre of paint would cover, and then how many coats would be needed. Something like that.
It's okay to say this, I think. There isn't a lot of use. I can't see for square numbers. There's no point dressing it up.
No, I agree.
It's just an interesting thing to learn, isn't it? If you, for example, you can relate it to finding an area of something, but that something would literally have to be a square. So actually, it might be worth talking about square numbers when you are looking and playing with Numicon resources, for example, or Unifix.
Are we allowed to
cubes
mention
and
other?
things like
We're allowed
that?
to mention other names.
Yeah, of course we are. But actually, thinking about it, it's shape, isn't it? So maybe square numbers should be introduced at a very, 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 very early age, just the language when they learn shape, because essentially that's what it is. A square is a shape with equal lengths. And actually, this is bizarre, but until I had to do my teacher training, this is going to sound really weird, but I didn't relate square numbers with squares.
Yeah,
I know that's ridiculous, but I related it with, it's that thing where it's got a little 2 at the top. And actually, it's just a square. So it could be, my advice would be introduce the language as early as possible.
Yeah, I think that kind of leads on to the other functional-esque or kind of real life problem, which you could use as a hook, would be about patterns, and say that someone's designing a pattern. I can't think specifically right now, but it grows as one small square and then a 2x2 square. It could be some sort of Lego pattern they're doing or something like that. And then it grows. And then questions such as how many tiles or how many small squares would you need for the 12th pattern? So it could be another one.
Yeah, and the obvious concrete exercise is to build square numbers, isn't it, with Unifix cubes? That's just something that's a very quick activity, isn't it?
But I like your point. I think it is one of those moments that when you realise that it is just
it's a square,
a bigger square.
Can you get rectangle numbers?
Yeah.
Can you get triangle numbers?
Oh yeah. Yeah.
I was thinking as well, when you use, I am going to name drop products, so Unifix cubes, and let's just say if you were building, you started with 1, then you did 4, then you did 8, 12, etc., and you built it up and up and up. Given that cubes are 3D and have 6 sides, is that
6 faces?
6 faces, sorry. Is that going to confuse the students? Or should you be using
that's
2D?
That's a really good point as well, isn't it? I think you just got to be clear about it, haven't you? That if you're using Unifix cubes to put 4 cubes to put together a square, if you like, then you probably want to keep it down on the table and just be looking at it as a plan view from above and to just see it like that.
Because otherwise they might get confused. Well, hang on, you haven't given me a square here. You go me a cube. Yeah. And if you look at, there's a lot of resources out there on the internet when you look at sort of practical exercises using cubes for square numbers. Just a thought. Don't want to go too deep into it, but
adamant maths, but it was fun. Fundamental.
So how would you represent square numbers pictorially? Just give us a couple of ideas.
Well, it's not the most exciting one to discuss, is it? With square, because there is really only one way, and it would just be, like we just said, to see it, to draw a square. What I do quite like, and this is quite hard to explain just over audio, would be to, let's say you just draw your one little square, just your one squared, and then keep that, and maybe just don't color that one in. So it's just a plain white square. And then you could draw the 3. So if your next one, your 2x2, the extra ones you're adding, then you could color or shade in. So you can see that you've had 1, and then you've got the 3 extras around the edge to make the 4. And then when you draw your next one, you've got your 4 already, and you draw your ones around the edge. Color those. And the way that's quite nice is you can see that you're adding the next odd number each time. So you're adding 3. So you got your first one is 1, then you add the 3 to get your next one as 4, and you add an extra 5 to get 9. Then you add an extra 7 to get 16. So that's quite a nice way to see that pattern grow.
Could we talk briefly about what would be your go-to reasoning question?
So you could say something like, I'll just use the number names, anti-clockwise, says that 5 squared is 10 because 5 times 2 is 10. Is she
Okay.
right? Do you agree?
I think it's really, really important to explore why things are written how they are. So,
Yeah.
for example, it's a bit like I'll start with the Chinese number system. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 0, 10, 1, 10, 2, 10, 3. So it's the vocabulary is place value, whereas our vocabulary is very abstract. So what is 11? What does 12 mean? What does 90? I suppose you got the 9 in there. So it's a very difficult number system to learn. So it's the same with symbols like equals. So I always say equals, and then I always say meaning it's the same as. So when we look over the number sentence again and we read it again, we say, I don't know, 2 squared is the same as, and I just think that's really, I know it seems like something very small, but exploring why things are written the way they are and exploring the language around that is really important, especially for students who have a learning difficulty.
Yeah, it's definitely something you shouldn't take for granted.
Okay, we'll move on.
Is it song time?
It is song time. So here is the square number song.
Square a number, there's a simple trick. Multiply the number by itself to get you it. Square a number, there's a simple trick. Multiply the number by itself to get you it. Square a number, there's a simple trick. Multiply the number by itself to get you it. Square a number, there's a simple trick. Multiply the number by itself to get you it. Come on!
Well, you boys look like a bunch of squares to me.
Yeah! The square root, well, that's the inverse fact. It's what you multiply by itself to give you that. The square root, well, that's the inverse fact. It's what you multiply by itself to give you that. The square root, well, that's the inverse fact. It's what you multiply by itself to give you that. The square root, well, that's the inverse fact. It's what you multiply by itself to give you that. Yeah!
Felt like my pies. You boys coming here talking about your maths again, boy?
I was wondering if you're going to do it live, to get a live performance. Yeah, questions. So I think I talked about this briefly on our first show. Is that it's one thing to watch a video or to share it, but it's also really useful to find out how much the students have taken from it. So just having some questions available to respond to the video would be really helpful. So that's what I'm kind of working on. So I'm just going to do a couple, maybe three questions, one from each of the different categories. And then what I'll do is I'll put a link to the full set of questions down below if for anyone doing this on YouTube. Is that okay? Does that work?
That's fine. That's fine.
Lovely. So we have the launch questions are questions directly related to the song. So I'll just pick one of those. Well, the first one is complete the line. To square a number, there's a simple trick, ... And children have to respond to that.
Okay, so they remember the actual what word I'm looking for. So they remember the trick itself.
Yeah. Well, it's complete the line. It's multiply the number by itself to get you it.
Yeah. Okay.
Then we have the autopilot questions, and these are ones just you straight up recall of facts kind of questions. So one of them is, what is the square root of 25? There is an extra part there. It says, "How do you know?" as well. So there's an invitation there to draw a picture.
Can I just
or
quickly
something
pick your
like
brain there? Go on then. How would you work that
Yeah.
out in your head?
that. In my head, well,
Yeah.
As I'm teaching it, I would encourage children to draw 25 as a series of small squares in the shape of a square. That's a
That's
bigger
a
square.
that's a lot to draw, though, isn't it? So let's just say you've got your higher ability or your adults who are just on the cusp of getting it. What would be a quick way of 25 times by itself?
Well, you are thinking of a number times by itself to make 25.
Yeah.
That's
Go on then. How would you work it out?
So-
In
Well,
your head.
in my head.
Yeah.
Well, you've got to know your times tables very well, haven't you? If you want to be able to do that.
So you could know your times tables
Straight
really
away.
well. You could even start associating with quarters, couldn't you?
I'm awfully sorry to pause the podcast at this point, but it appears that Sam and James have their wires crossed. Sam is talking about finding the square root of 25, whereas James is trying to find 25 squared. So if you'd like to skip this, that's absolutely fine. But I suppose it does make for an interesting conversation. Thank you.
I know people who would be associating with fractions because 25
Well-
obviously.
Quarters?
Yeah.
What do you mean?
Okay. So there's a relationship with 25 and quarters, isn't there? Because 4 25s are 100. Yeah.
Yeah.
And let's try. Okay. So, 8 times 25. What's a quarter of 8?
Quarter of 8. 2. Yeah.
2. So what's 8 times 25?
where we go?
And where are we going? Okay, let's start again. So 25.
200. 200, yeah.
Okay, 200, right? So 2 times 100 is 200. Oh, I don't know. Anyway, I'm right though, aren't I?
I think this would be a really good candidate for the outtakes. This sort of section.
Just do one more. Do one more. Okay. 25 times 12. Okay. Now let's work out a quarter of 12, which is 3. So I think 25 times 12 is 300. Am I right?
Yeah.
Yeah.
But
genius.
that's a completely different. That's a completely different thing you're working out.
It is. I'm not working out square root. I'm just saying, isn't 25 interesting because it's
isn't it?
related
Oh,
to a
yeah.
quarter. So therefore, it's quite easy to multiply anything by 25 because you work out a quarter first and times it by 100.
Well, I think that's another song for the future.
It is another song. I'm keeping that bit in because that's really clever.
Item of mass, but it was fun and fundamental.
The last set of questions are the hyperdrive questions. And these are really kind of getting into a bit of reasoning, just thinking a bit beyond the basic idea. So pick one from here. If you square a number, what can you do to get back to the original number? Give some examples to explain.
Mm-hmm.
Could be one. I'll do one more while still here. Can you spot any patterns with square numbers? Write down what you notice. So that could be where possibly looking at they go up by adding the next odd number each time. You add 3, then you add 5, add 7, and so on. But there might be other things. That's the beauty of these questions, that you get lots of surprises. Little surprises pop out.
We've talked about context. We've talked about methods. We've talked about questions. Talk to me about games. And talk to me about what games there are available for free on the website. Go.
Yeah, there are two games that I've made which can help practice square numbers. Now, one is called Cross the Bridge. So it's a little bit like the stepping stones, but not quite, where you've got to get from one end to the other along this bridge, and then by rolling a dice, and every time you land on if you land on a square number, you have to go back 3 spaces.
Yeah.
And the idea is to get from the start to the finish in 10 goes. So 10 rolls of the dice to get there. And the thing I quite like about the game, apart from practicing square numbers, is that it looks quite easy. But having played this with quite a lot of students at school, not many actually get to the end. Which is quite good. I quite like that.
Like it. Okay, so sorry, carry on.
Yeah, another one is Airlock. Now, this was very much inspired by. I'm going to mention a website. Shall I?
Yeah, we'll mention. But
yeah. Okay. So it was.
Let's put it this way: no one's listening to this, so you can mention what you want.
Yeah, it's true. So Joe Bowler's website, UCubed, has lots of games on there, and one of them was called "How Close to 100," and that's where you roll dice. Let's say you got 2 dice, so a 6 and a 2, and then you've got a grid of 100 squares, and then you would shade in a 6x2 rectangular block, and then you work out what the area of that is. So 6 times 2 is 12, and you write that down, and then you keep going for. Well, you can either have a limited number of goes, or you can play with someone else and be the first person to fill the grid, and so on. It's a really good way of practicing your times tables. Quite a fun way. So I've made a game called Airlock, which is very similar, except that there is a square numbers version. So it's a bigger grid than 100 squares.
Yeah,
I can't remember how many squares are on it now. But you roll one dice, and so let's say if you roll a 5, you have to square that one, and you color in the squares. So again, it goes back to that model that we talked about. There'll be 5x5 square made up of 25 little squares, and then you record down how many squares you've colored in. And same thing, it could be you could play with someone else, be the first to fill it in, or have maybe 10 goes and see who can fill the most.
Like, I don't know, Scoob. Adam of maths. Putting fun in fundamental, Scoob.
Right, Sam, I'm going to say any other business now. And there's a couple of things I would like to say, if that's okay. A few things, actually, if that's all right. So,
right.
Very, very quickly, I'm going to say there's my brother-in-law would ask a really awkward interview question. And I thought I'd put it out there to you for our massive audience to have a go at. If you were to have a Rubik's Cube, okay, and you were to paint the outside of every single face white, how many faces would you have that aren't white?
As if you sort of deconstructed the cube into 27 little cubes.
The reason why I asked that question was not because it was particularly a financial job, but he was interested in finding out the process of the thinking behind it. You know, what are they going to panic? Are they strategic in the way they're thinking? Do they need a calculator? Do they need to do a pen and paper? That kind of thing. And you can get more out of that than. And I thought it was just a really, really interesting thing. So
I think this would be a good opportunity to interact with our millions of listeners and ask them to put their answers down.
We might break the internet. So that's number one. And number two, I wanted to to give you that trick I was talking about. And I've done this before, and I did it the other day on a teacher in front of the students, and they were just, what? Oh, I can't believe it. So I'm going to read your mind.
Yeah.
Think of a number, 1 to 10. Don't tell me.
Yeah.
Don't tell me. Times it by 9. Don't tell me. Add the face value together. So if it was, I don't know, 51, it would be 5 add 1. Which would be 6. Yeah. Don't tell me. Take away 5. Don't tell me.
Okay.
If A equals 1, B equals 2, C equals 3, etc. Right? Think of the letter that corresponds to the number that's currently in your head. Don't tell me. Got it?
Yeah.
Think of a country beginning with that letter. Don't tell me.
Yeah.
Move on to the next letter in the alphabet. So if your country letter was, I don't know, A, Australia, you'd move on to B. All right?
Mm-hmm.
Okay. Think of an animal that begins with that letter. Don't tell me.
Yeah.
Are you thinking
Do
Denmark?
well, hang
elephant?
on. But before you, do you want me to say what I'm?
No. Are you
Do you wanna do
thinking
it while-
Denmark elephant? Are you thinking Denmark
No.
elephant?
No.
Oh, Jesus.
Well, no, I was thinking of Djibouti and Ewok.
Oh my. Right. Hopefully the listeners would have got mind read, but you obviously haven't because you've done this before, haven't you?
Well, I used to play a game we had to name all the countries around the world,
Yeah.
and I have to say, I hope I haven't offended anyone with the pronunciation of
Ewok.
Djibouti. Oh, it's Jib.
I'd just like to know why you think Ewok is an animal.
You're listening to Adam of Maths.
Don't forget to visit adamupmaths.com for completely free resources, tons of songs for every concept you could possibly think of, tons of worksheets and games and things like that. And it's all free because we don't know what we're doing. Bye. Say goodbye.
Oh, yeah. See you, everyone. Thank you.